Hi folks, welcome back. In the last video, we started talking about the structure of DNA and we were emphasizing the patterns found in its structure. The first pattern we discussed was the base pairing, how A always binds with T and G always binds with C. And today we're going to continue discussing patterns that we find in the structure of DNA. But let me first begin by reminding you of the 2D structure of DNA using this slide. DNA is actually two strands of nucleotides joined together in the middle where the bases are. Each base sticks into the middle and binds to the base across from it on the other strand. And like I said, there's a pattern to this binding. A always binds with T, and G always binds with C. The binding of the bases in the middle holds the two strands of DNA together, and this forms a structure that looks like a ladder. The sugars and phosphates of each nucleotide create the vertical backbone parts of our ladder, and the bases sticking into the middle create the rungs. So this would be like the backbone right here, and here's our bases in the middle creating that ladder structure. The pairing of the bases in the middle in the rungs happens using hydrogen bonds. The hydrogen bonds that hold the bases together I've indicated on this slide using these dots and dashes, all of those right there. And remember, all the rest of these bonds are covalent bonds. So DNA is basically two covalently bonded molecules held together in the middle by hydrogen bonds. But the hydrogen bonds aren't nearly as strong as the covalent bonds found throughout the rest of the DNA molecule. And this is critical to understand. The covalent bonds keeping the two vertical backbone halves of the DNA ladder intact are much stronger than the hydrogen bonds holding the two halves together in the center. And the covalent bonds are required for the integrity of the molecule. Therefore, if the covalent bonds keeping the two vertical backbone halves of the ladder intact are broken, it will destroy the DNA molecule. Conversely, the hydrogen bonds are weaker than the covalent bonds, and they're not required to maintain the integrity of the DNA molecule. Therefore, they can be broken and the two halves of the ladder separated without destroying the DNA molecule. Breaking the hydrogen bonds between the bases in the middle only separates the DNA molecule into its two strands. You still have two intact single strands of DNA. I'm stressing all this again because life depends on this structure of DNA. In order for DNA to function, in order to get the information that life depends on out of DNA, you have to be able to open up the DNA and get into the middle of it. You must be able to access the information that's contained in the bases. Life depends on the ability of DNA to be opened up, have its information accessed, to be closed back up again, all without being destroyed or being altered. And that's completely dependent on the structure of DNA. And that happens just like a zipper. Like a zipper, you can open and close it by sliding the clamp up and down along the zipper. This either joins or separates the teeth of the zipper, depending on which way you're going. But doing so does not destroy the zipper. The teeth are like the bases, with the hydrogen bonds holding them together in the middle of the molecule that can be opened and can be closed. But if you took the stitches out of the zipper would disintegrate. So the stitches are like the covalent bonds. They must remain intact or it falls apart. For DNA to exist and function, and for life to exist, it must always remain intact and unchanged. If not, the reproducibility of the structure and its functions is lost. Its information that's mandatory for life is lost, and so life itself is lost. Life ceases, or better yet, it can't even get started in the first place. That's why life is dependent upon the types and specific positions of the bonds that we have in DNA. Hydrogen bonds used to attach the bases to one another in the middle and hold the two halves of the DNA together are weaker than covalent bonds. They can be broken and remade without destroying the integrity of the DNA molecule. But that's not true for the covalent bonds. They're stronger than the hydrogen bonds, and they're of a different nature than the hydrogen bonds. The integrity of the molecule is dependent upon them. So destroying the covalent bonds destroys the molecule. The pattern of bond usage in DNA enables it to be opened up, have its information accessed, close back up again, just like a zipper, and remain intact and unchanged throughout. Therefore, life depends on the correct placement, the order, the choreography of each hydrogen bond and each covalent bond. Life also depends on the correct placement, order, and choreography of each atom of DNA necessary to create each type of bond. And to know the correct usage and placement of the bond types, you must also know the difference between the two. You must know which type of bond is required where in the DNA structure. Therefore, you must know the properties of a hydrogen bond and a covalent bond and the differences between the two ahead of time. You must know a hydrogen bond will work to hold the two strands of the DNA together in the middle, to allow it to be opened up, to allow it to have its information accessed, to allow it to be closed back up again, and yet remain intact and unchanged. You must also know that a covalent bond will not work for this. And then conversely, you must know that a covalent bond will work to hold all the nucleotides in each strand together so they do not come apart when the two halves are opened. You must also know that a hydrogen bond will not work for this. So folks, I'm hammering this for a good reason. If the hydrogen bonds are not in the exact place, DNA cannot open and close again and yet remain intact and unchanged, and life cannot exist. Alternatively, if you switch the type of bonds used and have covalent bonds where the hydrogen bonds are, and vice versa, DNA cannot open and close and yet remain intact and unchanged, and life cannot exist. Life depends on the pattern of these bonds. Therefore, it cannot be left to chance. And not only is there a pattern of bond usage, you must know this pattern ahead of time in order for DNA to be exactly as it is and for life to exist. Such an organized, intelligent, logical, ordered, choreographed pattern of bond usage requires both intelligence and prescience during the creation of the structure. You must know all these things about these bonds ahead of time in order to plan to intelligently, strategically, and intentionally use them in the design and the creation of DNA. This simply cannot be left to chance or randomness. Our DNA simply will not exist, much less function, and then life cannot exist. Because randomness, the hallmark of evolution, will not, cannot, and does not create patterns. It never has, and it never will. Randomness simply will not create the specific and life-essential pattern that we find in the bond usage in the DNA molecule. Randomness will create bond usage that's random. Random bond usage will not allow DNA to function or exist, which will not allow life to exist. Randomness, by definition, is the opposite of organization, intelligence, logic, order, choreography, and patterns. Randomness does not result from intelligence and prescience because it's random. Randomness would result in bonds being used in DNA in a random fashion. Randomness is like repeatedly rolling dice or repeatedly selecting a card from a deck of playing cards. You never know what you'll get. It always varies, and there's no intelligence, logic, organization, or pattern to it. It's also like telling a computer programmer to create a program by randomly selecting the figures he or she uses. Since we know ahead of time that computer programs and language, that's a binary code, if a programmer just randomly entered figures at their whim, you would never get a functional product. Now, my oldest son is a programmer, and he uses his skills to create video games for his game design company, Grim Tales. So he's going to be happy that I use that analogy. And that's the shirt I wore in the last video. Remember the Grim Tales shirt? Anyway, if the randomness of evolution created DNA, there'd be a complete disarray of bond usage with no structure, no order, no organization, no logic, and no pattern. Therefore, randomness, which is the basis of evolution, does not have the ability to create such organized, intelligent, logical, ordered, choreographed, and patterned structures like DNA. Therefore, just by looking at the pattern of bond usage found in DNA, we learn that DNA could not have come as a result of randomness or chance. Therefore, we have yet another scientific reason DNA could not have come into existence via evolution. And that's just from looking at the pattern of bond usage in DNA. And remember why we're talking about this, why patterns are so important. Remember when I talked about SETI and the design inference in one of my previous videos. Patterns tell us intelligence and prescience were involved in the creation of the DNA molecule. Randomness, the hallmark of evolution, would not and could not create anything with a pattern, much less a molecule with so much pattern in its structure. It would not and could not because randomness is random. So, we've already mentioned the pattern that we see in base pairing, where A always binds with T and G always binds with C. And now we have this pattern of bond usage. But there's more, much, much more. As I said, you find patterns all over the place in the design, structure, and functions of DNA. And I'm going to move on to more of them in the next video. So come on back for that. And if you like what you hear, give me a thumbs up and subscribe to my channel. Thank you very much for watching, and as always, we'll leave the light on for you.